In this video, we're going to work example problems where we solve systems of linear equations in two variables. Specifically for each problem, it's going to be two equations and two unknowns. Two linear equations and two unknowns. Okay, so there's two ways we can go about solving a system like this. We talked about in the textbook, you can use the substitution method or the addition method. And the way the textbook has the problems at the back of this section laid out is, for the first few problems that we're about to work, they suggest using the substitution method, and then for the next group of problems, they suggest using the addition method, and then for the problems at the end, they say we can use either method. However, just note that it really doesn't matter which method you use, that both will work just fine for problems like this. I think when they're suggesting to use substitution, the idea is for one of the equations, the coefficient on a variable is 1. So in that case, you can easily, just like here, we could solve for x. So subtract 3y from both sides of this first equation. It's easy to just solve for x and now plug this x into the second equation, and then we're going to have a linear equation in one variable, solve for y, and then we've got it. So, but if you don't have a coefficient of 1 on any of the variables, then they're suggesting to use the addition method. Since in that case you wouldn't have to deal with fractions, but again, it really doesn't matter. So let's do substitution here. Why not? I guess that's a good way to approach it. If you've got a coefficient of 1 on one of the variables, use substitution. I guess that seems logical. So okay, now we substitute for x. Here we plug in. All right, and now we've got a linear equation in one variable. So let's distribute that 3. Okay, minus 9 minus 2 is minus 11. And then subtracting 15 from both sides, minus 18 minus 15 is minus 33. Now dividing both sides by minus 11, you've got y is equal to 3. And so now we take y is equal to 3 and plug it into any of these two equations, or it would be easiest to just use this to get, and then solve for x. So x is equal to 5 minus 3 times 3, that's 5 minus 9, that's minus 4. So the point, the ordered pair here, this is the solution to the system. Okay, here, this is a little different because there's no x in this second equation. It's just a linear equation in one variable. But this is still technically, it's a system of equations because we're looking for, it's a little confusing because it's not going to be, yeah, it is, we're going to get an xy pair that solves both of these equations at the same time. It's just that the x won't pertain to this equation at all, but still, it's just technically a system of linear equations. So we're just going to solve for y here. So add 7 to both sides. I'll divide both sides by 3. You get y is equal to 3. Now plug y into this equation and solve for x. So 2x plus 7 times 3 is equal to 1. 2x plus 21 is equal to 1. 2x is equal to, subtracting 21 from both sides, you get minus 20. 2x is equal to minus 10. And so the point minus 10, 3 is the solution to the system of linear equations. It's just a little confusing because, yeah, minus 10, 3 solves this, or is the solution to this, but then there's no x here. You just plug in the y. Okay, so I think they want us to, they suggest using substitution here, but to me, let's go ahead and just simplify this and put it in the organized form, like the x term plus or minus the y term is equal to a constant. And then we'll go from there. So if we distribute the 2 here for the first equation, you have 2x plus 2y is equal to 2 minus y. Now, if we add y to both sides, 2x plus 3y is equal to 2. Okay? Now, let's do the same thing for the second equation. So, if we add 5y to both sides, okay, and then we add 1 to both sides, we get this. All right, so what we've got is 2x plus 3y is equal to 2, and then 4x plus 5y is equal to 3. All right, so here there's no variables with a coefficient 1, so let's use the addition method. But again, you could use substitution. It's not a problem. So what we want to do is let's multiply the first equation by 2. So 4x plus 6y is equal to 4. And then we don't have to do anything to the second equation. And now let's subtract these two. So we'll do minus. So 4x minus 4x is 0. 6y minus 5y is y. 4 minus 3 is 1. Okay. So y is equal to 1. Now we just plug y is equal to 1 into either of these equations and solve for x. So let's do the first equation. So 2x plus 3 times 1 is equal to 2. So 2x plus 3 is equal to 2. 2x is equal to 2 minus 3 is minus 1. So x is equal to minus 1/2. So the point minus 1/2, 1 is the solution. Okay, so yeah, let's do the addition method here. Why not? Since there's no coefficients of just 1 on a variable. So let's multiply the first equation by 6, or by 2. Okay, and then we don't need to do anything to the second equation. We've got because we have a 6x here, plus 5y is equal to minus 17. Okay, now let's subtract these two equations. Minus 14 minus 5 is minus 19. 2 plus 17 is 19, so y is equal to minus 1. All right, now let's just plug y into, let's say, the first equation. So 3x, 7 times minus 1 is positive 7. So 3x is equal to 1 minus 7 is minus 6. X is equal to minus 2. So minus 2 minus 1. Okay, let's organize each of these equations so we can add 4y to both sides on the first equation. Okay, now let's distribute that 2 on the second equation. So 2x minus 4y is equal to 22 plus y. All right, so subtracting y from both sides, you have minus 4y minus y is minus 5y is equal to 22. Okay, so we've got 11x plus 4y is equal to minus 5. 2x minus 5y is equal to 22. All right, so let's use the addition method. So, okay, we've got, let's see, we can match up let's multiply the first equation by 2. So we've got 22x plus 8y is equal to minus 10. And the second equation by 11. 22x minus 55y is equal to, so 22 times 11 is 22022. 242. So now if we subtract these two equations, you've got 8y plus 55y is 63y Minus 10 minus 242 is minus 252. So 252 divided by 63 is 4. So negative 4. Okay, so now let's plug in negative 4 into the first or the second equation. Okay, so 2x plus 20 is equal to 22. So 2x is equal to 2, x is equal to 1. Okay, so 1 minus 4. Okay, now for problems like this, the textbook advises us to clear the decimals or the fractions, but I mean, you don't have to, do whatever you want. But we can say, so 6/10 is what? That's 3/5 x plus 1/10 y is equal to 4/10. That's 2/5. Okay, then we've got 2x minus 7/10 y is equal to 3/10. Okay, so multiplying the first equation by 10, we're going to get 6x plus y is equal to 4. Multiplying the second equation by 10, we get 20x minus 7y is equal to 3. Okay, and so now we can, let's use the substitution method. So we've got y is equal to 4 minus 6x. Okay, now let's substitute that into the second equation. So 20x minus 7 times 4 minus 6x is equal to 3. So 20x minus 28 plus 42x is equal to 3. Okay, so 20 plus 42 is 62. 28 plus 3 is 31. So x is equal to, that's going to be 1/2. Okay, so now plugging 1/2 into this for x, you've got 4 minus 3, so y is equal to 1. So 1/2, 1. Okay, we can use the addition method here. So let's multiply the first equation by 3. 6x plus 33y is equal to 12. Okay, multiply the second equation by 2. 6x minus 12y is equal to 10. All right, so now let's subtract these two equations. You could add or subtract, whatever works to eliminate a variable. So 6x minus 6x is 0. 33 plus 12 is 45. 12 minus 10 is 2. So y is equal to 2 divided by 45. Okay, so now let's just plug in that y value to either one of these equations and get x. So we've got 2x plus 11 times 2 over 45 is equal to 4. So 2x plus 22 over 45 is equal to 4. So 2x is equal to 4 minus 22 over 45 is equal to, let's see, let's just use our calculator for this. So 4 minus 158 over 45. Now divide both sides by 2, and you've got, what's 158 divided by 2 is what? Well, this whole thing divided by 2. 79 over 45. So, 79 over 45 2 over 45. Okay. Okay, so let's put this. So we've got 3x minus 4y is equal to 6. And then we've got 9x minus 12y is equal to 4. Okay, we can multiply the first equation by 3 and get 9x minus 12y is equal to 18. Okay, so now if we subtract these two equations, we see that we're going to get 0 is equal to 14, which is never true. So this is a system that has no solution, and this is called, that means that this is inconsistent. The system is inconsistent. There is no xy pair. So of all the xy pairs in the entire xy plane, there's not one pair that when you plug it in here, it's a solution to the equation. Okay, let's see. We can start by, let's clear the fraction in the second equation. All right, multiply that entire equation by 3. And so what you can see is we've got the same equation here. Well, they're not. It's not the same equation because this is just this equation is this equation multiplied by 3. So they just differ by a constant. We get 0 is equal to 0. Now this is different for equations in one variable in chapter 1. When we got something like this, that meant that the unknown variable, the solution, was all real numbers. You could plug in any number on the number line, and it solved the equation. But remember, it's a little bit different with systems of equations because you might be tempted to think that, okay, any point, xy point, solves this system of equations, and that's not the case. It's not any xy pair in the entire plane. No, that's not what solves it. It's any point on. These are the same line, right? Even though that these aren't technically the same equation because one is if you multiply this by 3, you get this equation. But because they're just the entire equations are just a constant multiple of each other, then that means they're the same. They represent the same line. And the solutions to this is all numbers or any xy pair on that line. So what's that line? Well, okay, let's just get the most simplified form of the equation of the line. So we can take this and do y is equal to minus 3x plus 6, and we would divide out a factor if we could, but we can't divide out any factor without getting fractions. So this is the solution. It's you write it this way: y is equal to minus 3x plus 6, where x is any real number. I mean, I'm not sure if that's how you write it from a technical math perspective, but so okay, if we plot this, let's see, 1, 2, 3, 4, 5, 6. That's the y-intercept, and then you do. So we go rise down 3 over. Oh, we're going this direction. Down 3, 1, 2, 3 over 1. Down 3, 1, 2, 3 over 1. So it's any point, the solutions, if you plug in take any xy pair off this line and plug it in here, it's going to solve that system, which is it's an infinite number of solutions. It still isn't. It is in the same way that for an equation in one variable, if you had x is all real numbers, that's an infinite number of solutions. It's the same here in that sense because this line goes off to positive and negative infinity. Okay, let's see. Let's clean these two equations up. So if we subtract or add 5y to both sides of the first equation and then subtract both sides by 4, we get this. Now the second equation, let's distribute that 4 is equal to 7y plus 2. So 4x subtracting 7y from both sides. Okay, so we've got 4x minus 3y is equal to 0. Now let's multiply the first equation by 2. You get 4x plus 10y is equal to 0. And we don't need to do anything to the second equation. And I keep matching up the x's to subtract out the x terms, but you could use the y terms as well. It doesn't matter. So we could have multiplied. I'm just doing what's simplest. We could have multiplied this equation by 3 and this equation by 5 and gotten 15 y's, but then you'd have to multiply a factor by both equations. So why not just do the first equation by 2? That seems simpler. It doesn't matter though. So subtract these two, and you've got 10 plus 3y is 13y is equal to 0. So y is equal to 0. Dividing both sides by 13, okay? So now let's take the first equation here. We've got 2x plus 5 times 0, 2x is equal to 0, so x is equal to 0. So the solution here is the point 0, 0. Okay, we can use substitution because we can easily get, if we solve for y here, you've got y is equal to, you added y to both sides and then you subtract 6 from both sides. Okay, so now let's plug this in to the second equation. So minus 5x minus 6 plus 6. So 10x is equal to minus 2 times minus 5x, because minus 6 plus 6 is 0. So 10x is equal to minus 2 times minus 5x is 10x. So dividing both sides by 10x or subtracting 10x from both sides. Okay. So this is it has an infinite number of solutions, but again, it's not, don't say it's any XY pair. That's incorrect. You have to make sure you make that clear. It's going to be any, all you do is you take any of the equations and put it in y-intercept form and simplify it as much as you can. Like put, if we had 2y is equal to minus 10x minus 12, well then divide the 2 out. So this is a nice simple form of the line. So it's, it's any y is equal to minus 5x minus 6, where x is any real number. That's the solution. If you plug in any xy pair with this constraint on this line into this system, then that solves the system. It is not any xy pair in the entire plane. It's any xy pair on this line in the plane. Okay, so we can use substitution here. Let's just, we already have x. Let's plug this x into the first equation. So 3 times 5y plus 800 minus 10y is equal to 1900. So 15y, 8 times 3 is 24. Okay. All right, 15y minus 10y is 5y. And then 1900 minus 2400 is minus 500. So y is equal to minus 100. Okay, so now plugging in minus 100 into this second equation, 5 times minus 100 is minus 500 plus 800. X is equal to 300. So 300 minus 100. Okay, let's start by clearing the fractions. So if we multiply this first equation by 3, you've got 3y is equal to 2x minus 3. If you multiply the second equation by 6, you've got 6y is equal to x plus 12. Okay, now putting these in that more organized form, you've got 2x minus 3y is equal to 3, and then you've got x minus 6y is equal to minus 12. Okay, let's multiply the second equation by 2. 2x minus 12y is equal to minus 24. Now subtract these two equations. Minus 3 plus 12 is 9. 3 plus 24 is 27. So y is equal to 3. Now let's plug y into, I guess, this first equation here. So x plus 12 is equal to 6 times 3 is 18. So x is equal to 18 minus 12 is 6. So 6, 3. Okay. Let's multiply the first equation by 2. 4x is equal to y plus 2. And the second equation, let's multiply by, so this is, let's see, let's rewrite the second equation. So 4 divided by 100 is 1 over 25. Then we've got 1 divided by 100. Then we've got 2 divided by 100. All right, so we multiply the first equation again by 2. 4x is equal to y plus 2. And the second equation, we multiply by, let's multiply by 100. So that's going to be 4x minus y is equal to 2. So we've got 4x minus y is equal to 2, and then 4x minus y is equal to 2. It's the same line. So let's get the simplest form of this line. We can use this equation. Y is equal to 4x minus 2, where x is any real number. It's any point on this line solves this system. And that means that whenever we have a case like this, that means that the two equations are dependent. You don't call this an identity. You say the two equations are dependent. Or however many equations there are, they're dependent. Okay, let's multiply the first equation by 8. So you have x minus 2 plus 4 times y plus 1 is equal to minus 6 times 8 is minus 48. Let's multiply the second equation by 4. So you have 2 times x minus 2 minus y plus 1 is equal to 48. All right, so we've got, let's see, x minus 2 plus 4y plus 4 is equal to minus 48. Okay, 2x minus 4 minus y minus 1 is equal to 48. All right, so let's see. X plus 4y plus 2 is equal to minus 48. And then we've got 2x minus y minus 5 is equal to 48. So we've got x plus 4y is equal to minus 48 minus 2 is minus 50. And then we've got 2x minus y is equal to 48 plus 5 is 53. Okay. So, let's multiply the first equation by 2. All right. Now so subtracting these two, 8y plus y is 9y, minus 100 minus 53 is minus 153. And let's see, what is 153 divided by 9? 17. So y is minus 17. So now let's plug y is equal to minus 17 to this second equation. So x plus 4 times minus 17 is equal to minus 50. Okay, 17 times 4. Okay, x minus 68 is equal to minus 50. X is equal to minus 50 plus 68 is 18. So 18 minus 17.